Welcome everyone to training today for Arnold's custom seeding. Today we're going to talk about phosphorus. Is it purple or is it green is kind of the motto of this training session. So we'll get started and see what we can learn today. The top slide here is a picture of a plant that has phosphorus deficiency. And you'll notice that the leaves on this plant are purple in color. That purple shading of the leaves indicates a phosphorus deficiency. So if you see this out on the right of way, you can say to yourself, we must be lacking a little bit of phosphorus out here. The one thing to remember though is that if you have cold weather conditions or very wet weather conditions, this phosphorus deficiency can show up even though there's adequate phosphorus in the soil. And that's because the plant just can't take it up at that point. As soon as it warms up or dries a little bit, you'll start to see that phosphorus deficiency go away. The bottom slide or bottom picture here is of a surface water body with what we call eutrophication or an algae bloom in it. Most of the time this is caused by too much phosphorus being put into the surface water body and phosphorus being the limiting constituent or limiting nutrient for the algae to grow. Once that phosphorus goes in there, it becomes bright green like that. So that's kind of where, is it purple or is it green? Too little, too much. So just kind of wanted to get you guys to understand that both can be a problem on this. Again, we're back to the 4 R's of nutrient management that we've talked about in previous discussions. Right source, right rate, right time, right place. Again, we're going to stick mainly for these discussions to the right source and right rate because that's what we're going to be dealing with most of the time. We really can't change timing, and placement is usually going to be broadcast in a pipeline right-of-way reclamation process. Over here we have a bag of triple superphosphate. Again, let's go through the numbers. 0 stands for the nitrogen percentage in that. We have no nitrogen in this product. 45 is the phosphorus content of this, so there's 45 pounds of phosphorus for every 100 pounds of product. And then there's 0 potassium in this product. This, again, triple superphosphate, very common source of phosphorus, especially if we don't need nitrogen or potassium in there. The sources of phosphorus that we may be using out there include MAP, which, as we talked about previously in the nitrogen discussion, stands for monoammonium phosphate, which is 48% phosphorus. And if we remember back in the last conversation, it also has 11% nitrogen. So we get about 11% nitrogen along with the phosphorus. DAP is diammonium phosphate. That has 18% nitrogen, 46% phosphorus, and 0 potassium. DAP is very used quite frequently because you get 18% nitrogen along with a high phosphorus amount. And then the last one is triple superphosphate, TSP, which is 45% phosphate but has 0 nitrogen and 0 potassium. So it's only really used when we don't need those other nutrients to be added. A couple other sources of phosphorus that we have used in the past include Richlawn, and that the phosphorus in that product varies from 1 to 5%, and it also has potassium and nitrogen with it, but in low values also. So it takes a lot of this product to get adequate amount of phosphorus. Compost, very similar, 1 to 3% phosphorus in that, but you also get some nitrogen and some potassium along with that. So we've talked about nitrogen in the past and how important it is to plant growth. Now we're talking about phosphorus. And people sometimes confuse that these two are similar in how they act in the soil and how the plant takes them up. Well, I'm going to use the analogy of your fuel versus your oil in your car. Nitrogen is like the fuel or the gasoline in your car in that it has a high usage. We use a lot of gallons of it. The crop stops, or the car stops, when you run out of gas. When you run out of nitrogen, the crop stops growing. But the nice thing about nitrogen is it is easy to refuel the car when you're out of gas. Phosphorus, on the other hand, is more like the oil system of your car. We don't use a lot, quarts of oil for, 3,000, 5,000 miles. The crop keeps growing even when we run low on oil. Just like your car, you can be way low on oil and keep running. Might not be the best thing for the car at the time, but you don't notice it until a disaster breaks out. And then, as I say, not good when you realize that you're out of oil or out of phosphorus. It takes a lot to build it back up or to rebuild your engine, per se. So when you're thinking about these two, just think about them in those two facets, and you'll kind of understand why we need to worry about these a little bit differently. And that's because pH matters. Okay, on this graph, we have percent of total phosphorus in the y-axis and the soil pH in the x-axis. As you remember from previous discussions, if we have a low pH, we can add lime to the system to raise the pH up to our desired pH of 6.5 to 7, which is near neutral. If we have a high pH and we want to bring soil pH back down, we add sulfur or other acidifying agents, again, to get it into this general range. This graph is showing all the different phosphorus sources that are in the soil, but notice here on the top is the relatively available phosphorus for the plant growth. And it's a thin band except for in this narrow pH window that we have there. And that's why having the correct soil pH is very critical for phosphorus. And when these phosphorus, they all interact. So this phosphorus will feed into here, this one will feed in, these will feed in. And as these are depleted, we add more readily available, they'll go back to make an equilibrium. So when the plant withdraws phosphorus from here, more will come into solution and be available to plant. Not the same amount, but some will. So when we deplete all this up here, then add phosphorus back to it, we have to replenish everything in there that we've taken away. So it takes more than just a little bit to add that back in there. And some of it will be plant available, and others will not be plant available. So that's what makes phosphorus management a little bit more difficult than, say, nitrogen, and why it acts more like oil than gas. Test results. We concentrate on phosphorus on two different tests. One is total P, which is that whole graph. And then the other one is a plant available P, which was that small little stuff at the very top. Total P we use mainly for environmental reasons. This tells us what impact phosphorus possibly has. Will it run off into streams and cause problems there? It's not so useful in the reclamation on telling us whether the plant's going to be satisfied or not satisfied. That's why we have to use a plant available P test. These tests are indexes, not actual true values. So what I'm saying there is that in the index, research has done a whole bunch of experiments that says if your P number is this, and you add this much phosphorus to it, your plant will reach 100% yield. It's not that you have this much phosphorus in the soil. And then we also have a whole bunch of different tests, But if you use the wrong test, you might get the wrong result. So, you know, we have the Bray 1, Bray P, Mallet 3, Olsen P, and ammonium bicarbonate test. The Bray 1 test is very useful for acid soils. Soils pretty much east of the Mississippi River. Bray 3 test kind of tells us how much P will become available from the other sources. So it is very unuseful in the reclamation industry. The Mallet 3 test has been developed for southeast soils more than any other, but it's becoming more widely adopted throughout the United States. The Olsen P test is only good for pHs of greater than 7.2, so it doesn't work well for the eastern United States, but works very well for the western United States. And then the ammonium bicarbonate test is a test that was developed strictly for western soils, front range soils pretty much. And this is what Colorado State Slab uses mostly on testing. But the problem is that if you have a soil test result of 12 for a Bray and 12 for an Olsen, it's not the same result. It means two different things. I'll show you an example of this here. So like I said, if we use 12 as the example from an Olsen test, you see that we are in the high range here. And we need very little phosphorus. Zero phosphorus is probably what we'd put on it. But if that same 12 test came back from a Bray test, 6 to 12, we would need 30 pounds of P2O5 added to the system. Very different amounts of phosphorus, very different results. And then if we use Mallet 3, we're somewhere in the middle, so we might need a little bit more than 30. So you can see these tests, we have to know what tests we're reading to be able to interpret them correctly. So when you go and look at a soil test results for phosphorus, make sure you understand what test that was being conducted on. So again, how much is too much phosphorus? As we've always said with all the other nutrient management, what's your crop? Some crops require more phosphorus, some require less. If you're growing something like alfalfa, you better have a lot of phosphorus. Roots need phosphorus. Corn needs a little bit less phosphorus than other crops. Native range grass, they need just enough phosphorus to keep the nutrient cycling going. Time of the year. We don't want to be putting a lot of phosphorus down at a time of the year where plants won't use it and it has high potential to run off. So if your wet season or high erosional season is during the fall, winter months, we wouldn't want to be putting phosphorus down at that point because we'd lose most of it and start causing that algae bloom we saw in that first slide. Again, background soil P test, but also which background soil P test? Did you use a Bray? Did you use Mallet? Did you use Olsen or ammonium bicarbonate? We need to know that so we can make a correct interpretation of that soil test result. Site-specific conditions, as we've said many times before. And then, so that's all I have to talk about today. P tests are very critical. P is very critical for reclamation success. If you have any questions, feel free to give me a call or stop by my office. And I appreciate your time today.